Okay, so far we've been talking about points and intervals on which a function is continuous. So what happens naman if a function is not continuous on a certain value of x? Well, if that's the case, when we have a discontinuity, and we have several classifications for discontinuities. So first classification natin ay removable discontinuity. So removable discontinuity at x equals c when, okay, so this happens when yung limit natin exists. So the limit as x approaches c exists. Okay. However, it's not equal to the value of the function at x equals c. Okay, so limit as x approaches c exists, but this limit is not equal to the value of the function at c. So there are two possibilities here. Let me just get my line tool. So halimbawa, andito yung x equals c. Ayan. So itong equality na to, or inequality rather, this will be true when our function is not defined at x equals c. So meron tayong whole, x equals c, and then ito yung graph ng function. Ayan, for example, that's one possibility. And the other possibility is this. So suppose andito yung c. Ayan. So again, merong whole yung function at x equals c. Ayan, merong whole tayo. Pero yung function natin defined actually at x equals c. Hindi nga lang ito yung value niya. It's somewhere else. Halimbawa dito. Ayan. So these are the two possibilities on which we have a removable discontinuity. Okay, so let's look at an example. So suppose gusto kong malaman kung ano yung mga discontinuity ng f of x is equal to x squared minus 4 over x minus 2. So a function will be discontinuous when it is not defined. Okay. So saan hindi defined itong function natin? It will be when x is equal to 2, since yung denominator natin ay magiging 0. Okay. Now, to show na removable yung discontinuity natin, we need to show that this holds. So, ano nga yung value ng function natin when x is equal to 2? Well, the function is not defined at x equals 2. It's not defined. Okay, but yung limit as x approaches 2 ng function natin na x squared minus 4 over x minus 2 is equal to, how do we evaluate this limit? First, let's factor out the numerator. It's x plus 2 times x minus 2. The denominator is x minus 2. Makakancel yung x minus 2 at ang matitira ay x plus 2. Therefore, the limit is equal to 4. So, the limit exists, it's equal to 4, but the function is not defined. Okay. When x is equal to 2. So, therefore, meron tayong removable discontinuity. So, f has a removable discontinuity. at x equals 2. Okay. So, bakit nga ba removable discontinuity ang tawag dito? Well, from the term itself, it's called a removable discontinuity since literally we can remove the discontinuity. So, how do we remove the discontinuity? If this is our case, kung meron tayong hole dun sa function natin at hindi defined yung function at x equals c, we can just go ahead and plug that hole in. So, since hindi defined yung function, but the limit exists, we can define the function to be the limit at x equals c. So, ganun din dito. So, mangyayari, itong point dito, we just need to move it back into the hole. Well, not really move it back, but move it into the hole. So, to redefine this function, so redefining, so removing, to remove the discontinuity. Okay, so we set f of x to be equal to x squared minus 4 over x minus 2. So, hindi natin ginagalaw yung definition ng function on values where the function is continuous. So, ito yung value niya, it's still the original value when x is not equal to 2. But when x is equal to 2, we will define the function to be the limit when x approaches 2. And we just computed that, and it's equal to 4. Okay. So, after redefining the function, itong function na to, wala na siyang discontinuity. Na-remove na natin yung discontinuity. And in fact, this function is continuous everywhere. Now we have another kind of discontinuity, and it's called an essential discontinuity. Kung dito sa removable discontinuity, nag-exist yung limit natin, hindi nga lang equal dun sa value ng function. For essential discontinuities, the limit does not exist. Essential discontinuity at x equals c if the limit as x approaches c ng f of x does not exist. So, kailan to mangyayari? The limit will not exist if yung limit from the left is not equal to the limit from the right, or when the limit is either positive or negative infinity. And because of those two possibilities, meron tayong dalawang klase ng essential discontinuity. So, number one, meron tayong jump discontinuity. Or jump essential discontinuity if yung limit from the left is not equal to the limit from the right. But both of these exist, okay? So they are both equal to some constants, pero hindi nga lang equal. So graphically, ito yung nangyayari. Suppose nandito yung c, and then ito yung function, ito yung itsura ng function from the left of c. So kung ano man yung value ng y coordinate dito sa hole na to, yun na yung value ng limit from the left. But from the right, suppose you have something like this, and as you can see, the graph of the function jumps from here to here, and that's why we have a jump essential discontinuity. Now, the other kind of essential discontinuity is the infinite essential discontinuity. And this happens if we have an asymptote at x equals c. And when does that happen? It happens if the limit as x approaches c from the left is equal to positive or negative infinity, or the limit as x approaches c from the right is equal to positive or negative infinity. So there are many ways. Actually, itong sinulat kong dalawang limits, these are 4 individual conditions that can hold. And if one of those conditions hold, then we have an infinite essential discontinuity. So halimbawa, c ay nandito, and then meron tayong asymptote at that value of c, ganyan. It's enough na yung one side goes to positive or negative infinity. So kung na-show na natin na pupunta siya ng infinity kung lalapit tayo ng c from the left, then you don't have to evaluate the limit towards the right of c. Just to show na meron ng infinite essential discontinuity at x equals c. So kung meron na tayong asymptote established here on the left side, pwedeng wala tayong, pwedeng yung limit from the right is just a constant, yan. Or pwede ring asymptote. Okay, so let's look at an example. So let's identify the discontinuities of this piecewise defined function. Okay, so the function is equal to x plus 1 over x minus 2 when x is less than 1, and it's equal to 2x over x plus 3 when x is between 1 and 2, and it's equal to 1 over x minus 3 when x is greater than 2. Okay. So if a problem asks you to identify the discontinuities of a function, you would have to check endpoints of intervals. So ito yung i-check natin to check. So una, endpoints of intervals. So ano yung mga endpoints of intervals natin? Let's look at these 3 conditions. Yung mga endpoints ay 1 and 2. Okay, so we're going to test those later. And then, yan. So endpoints of intervals. And then, values on which f of x is not defined. So ano yun? Well, itong x plus 1 over x minus 2, it's not defined when x is equal to 2. Kaso yung x equals 2, labas nitong interval na to. And also, 2 is already an endpoint. Okay. So, no additional value to test from this expression. Ito namang 2x over x plus 3. This is not defined when x is equal to negative 3. Kaso yung negative 3, nasa labas naman itong interval na to. So, hindi na natin kailangang test. And then, itong 1 over x plus 3. This is not defined when x is equal to 3. Now, here, in this case, 3 is inside this interval. Or rather, 3 satisfies this condition. So we would have to check 3 as well. So ano yung mga i-check natin? Yung endpoints of intervals, we have x equals 1 and x equals 2. Values on which f is not defined, we have x equals 3. So test muna natin yung x equals 1. Let's evaluate the limit as x approaches 1 from the left, and then compare it with the limit as x approaches 1 from the right. So from the left of 1, okay, sorry. Actually, ang gusto kong gamitin na function is x minus 1 ito. Yeah. For illustration purposes, I want this to be 1 instead of 2. Okay. So what's the limit when x approaches 1 from the left? So x will take values less than 1. So we will use this definition of the function. Okay. So the limit as x approaches 1 from the left of f of x is equal to the limit as x approaches 1 from the left of x plus 1 over x minus 1. Okay, so yung limit ng numerator natin ay 2. Ayan. And then, yung limit ng denominator natin ay 0. So, meron tayong positive or negative infinity. Now, the question is, how does the denominator approach 0? Okay, when x approaches 1 from the left. Okay, let's, kung hindi nyo maisip agad, you can just take some test values. For example, 0.99 is a number which is less than 1. So 0.99 minus 1 is negative. So we have 2 divided by 0, and the denominator approaches 0 from the left. So therefore, yung limit natin ay negative infinity. And immediately, since infinity yung limit natin, yung x equals 1 ay infinite essential discontinuity. So, infinite essential discontinuity at x equals 1. So, hindi na natin kailangang i-test yung limit as x approaches 1 from the right. We're done with 1. Let's test 2. So, limit as x approaches 2 from the left. Okay. Kung galing tayong kaliwa ng 2, ito yung gagamitin natin. We have 2x over x plus 3. And the limit is just 4 over 5. Now, if we approach x from the right of 2 to greater than 2, ito yung gagamitin natin. Okay, we're using the function 1 over x minus 3. And this is equal to, we're just using substitution here. Katulad dito, nag-substitute lang tayo ng x equals 2. And here we have negative 1. Okay, so magkaiba yung limit sa kaliwa ng 2 at sa kanan ng 2. Therefore, meron tayong jump. Essential discontinuity at x equals 2. Okay, so we're done with 2. X equals 3 naman. By the way, I'm starting here from the left. But, of course, you can always try evaluating the limit from the right of the given constant first. Okay, so let's evaluate this limit. So itong limit na to, since yung x will be approaching 3, so ito yung gagamitin nating definition. 1 over x minus 3. Yung limit ng numerator natin ay 1. Yung limit ng denominator natin ay 0. Okay? But it will approach 0 from the left. So therefore, negative infinity yung limit natin. At meron tayong infinite essential discontinuity at x equals 3. Okay, so we're done.